So the cooling fan is turned off when the initial angular velocity is 850 revolutions per minute. And we can multiply this by 2 pi radians for every 1 revolution times 1 minute for every 60 seconds. And this is going to equal 89.012 radians per second. It comes to a stop, so the final angular velocity is going to be 0 radians per second, and then it makes 1,250 revolutions during this time. And we can convert this to pi radian for every 1 revolution. And this is going to be equal to 7,853.975 radians. At this point, we can say to find the angular acceleration, we can use angular kinematics and say that omega final squared equals omega initial squared plus 2 alpha delta theta. And this means that alpha is going to equal omega final squared minus omega initial squared over 2 delta theta. We know that the omega final squared is going to be 0, so this is going to be negative 89.012 squared divided by 2 times theta. In this case, it will be 7,853.975. And we find that alpha, the angular acceleration, is negative 0.504 radians per second squared. Now, to find the total time it took for it to stop, we can say for part B, omega final equals omega initial plus alpha t. And we know that omega final is going to be 0, so t simply equals negative omega initial over alpha. And this will be negative 89.012 divided by negative 0.504. And we find that t is going to be 176.1 seconds. So this will be your answer for part B. This will be how long it takes for the cooling fan to cease motion. And then this will be your answer for part A. What is the angular acceleration as it slows down from 850 revolutions per minute to rest? And that's the end of the solution. Thank you for watching.